Hey everyone, so I'm back with the Gigabyte Aorus Z590 roundup that you didn't get on the actual launch day. Now the reason for that was the BIOS at launch, pre-launch, really wasn't good from Aorus, so I've waited, gave them a few weeks to get things up together, and now we're back to see what they're like. And it might be one you want to get comfortable for, because sadly it's not all, or if any, good news. Okay, so we'll start with scan around each of the boards, and we will go with the ITX first. Now obviously it's an ITX form factor, only got 4 screws on the board. That also means it's only 170mm square. You can fit it in normal cases if you want. It's just a lot smaller, but most people put these in ITX cases. Now you do get a shielded 8-pin in the top left-hand corner, and then your only on-board native fan up here for the CPU, but you do get 3 other fans because they're wired with these little connector cables that clip in at the top, and it's just so that they can save space. But what it also does mean, if you're building in a nice case, you can kind of wrap the cables around and save some space anyway. So you get 3 further ones at the top, so that's 4 fan headers in total, and that is all there is on the board. Don't forget though that you can use fan out cables, PWM fan out cables, or even get yourself a PWM hub. 2 shielded DIMM slots. It's Z590, so very high speeds that you can get with the DIMMs. Just don't forget it's going to be CPU dependent. And by that I don't mean the difference between an i5 and an i9. I actually mean you can have all i9s, and some of them will actually do higher memory speeds, and you do have to adjust voltages and stuff. It's not quite as simple as just buying a 5000 megahertz kit and hoping for the best. 4 SATAs on board, USB 3.2 external, and then you've also got another one down here as well. So you've actually got all of the kind of most expensive fittings on. You've got 2 USB 2s here on this, again, fan out cable, but it does come with the condiment cables, and by condiment I mean it looks like ketchup and mustard. And this really lets the side down and makes it look cheap, makes it look like they don't care. This is black. It's all nice. This isn't. Underneath here is your chipset, but there is a PCI Express 4 M.2 slot as well, and it's kind of like a tower one. It's all built in, so it does give you PCI Express on the board. There is also a PCI Express 3 on the back of the board. Now you either need to plan carefully, because obviously you'll have to take the motherboard out to be able to access it, but if you've got a CPU cutout on the back of your mini ITX case, maybe think about extending it a little bit so that you can get access to it from the back. Obviously it's going to depend whether you've got a vertical ITX or a horizontal ITX mounting, but it will give you some options. Then round the back you have a lot of options. You've got your audio down here, Wi-Fi 6, 2.5 gigabit Ethernet, a lot of wind in the background knocking stuff off because the window's open, USB 3.2 over here, and you've got a Type C and a Type A. More USB 3.2, USB 2 here. Now you do get a DisplayPort and a HDMI, but that's only going to work if your CPU has an onboard GPU. If it doesn't, then you're obviously going to need a dedicated graphics card. So for argument's sake, any of the F series processors, like the 11400F, these will not work at all. So please keep that in mind. Integrated I/O shield in the back, big heatsink for the VRMs. Now with the VRMs, it is a 10+1 phase digital VRM, and they're 90 amps per power stage. Now this is a big chunky monkey heatsink that kind of wraps around the back, but when we come around here, what you can see is comes up and then along. This bit here is actually plastic. So the heatsink itself is smaller than you might first believe, but there is a really nice heatsink here with all the multiple fins. Now, it does look a little bit old school, but because there are lots of fins on it. It means that the surface area is greater. So this actually cools better than a big chunky one like this. So this is actually a really nice thing, but I do think it still looks kind of small. But we'll see what the VRM temps are like later. You get a support brace around the back as well, because there are a lot of electrical components around the back, because the back plate is part of the cooling for the motherboard. Onto the Pro AX, full-sized ATX board. This obviously because the other one was an ITX. The normal layout that you would expect. Now, this is your PCI Express 4 NVMe slot. There are 3 more hidden underneath in total. You get a fan header up here, which is sysfan 1. Couple of CPU optional fans here. Going around the outside of the board, got another sysfan here. Although this is marked up as sysfan 6, but also pump. So this could be good for those of you out there that are looking for an AIO or water cooling. Following on around the outside of the board, there are 3 fans down the bottom corner here. Now, where we would normally see, or sometimes see, a fan around this area, there isn't one visible at all. So if you are using the rear fan that would normally plug in here, flip it around, put it up here, it would probably end up looking tidier anyway. USB 3.2 here, and then you've got the C option as well as the normal option. 6 SATAs down the side. You do get a addressable and a normal RGB header up in the top right hand corner, and there is another one down in the bottom corner here. And then while we're here, I can also show you the normal USB 2 header here. This is your front panel, and then you've got some Thunderbolt stuff down the side here as well. It's also nice to see that the battery isn't hidden by any like shields or anything like that. So if you do need to do a BIOS clear in that way, you've got easy access for it. Then the power solution around the outside is a 12+1 phase. It's digital again, and it's 90 amps per phase. Now you can see the old school heatsink down the back, which should be good for heat dissipation, connected with a heat pipe to the top one. This is where most of the VRMs and phases are going to be, so that's why they've concentrated on this, but they have covered it in plastic, so there's not a great deal of like active airflow that you can put on it. There's no fan or anything, so despite the fact it's quite good, it's kind of hindered as well. The back heatsink isn't just a chunk of aluminium. There are some cutouts on it to aid with surface area, so we'll have to see how this does later on in the review. Around the back, it's quite plain, apart from the built-in I/O shield actually being screwed on to the back of the board. And then we go around there, there's quite a lot of connectivity, which for Z590 is kind of what you'd expect because of the price involved. There's only a display port for onboard video, but what you need to remember is again, as I've said previously, you need to make sure that your CPU has onboard video support. USB 3.2, normal USB 2s, you've got a C there, 2.5 gig Ethernet. You've got your onboard audio, which does have Japanese capacitors and your amp up audio, they call it. It's kind of concealed underneath here, but there is like a separate part of the PCB to help keep things clean. So yeah, lots of connectivity on this one, but then the price does kind of warrant it. Okay, so the master, the big daddy board, 18+1 phases, all 90 amps per power phase. You can see it's got a proper crazy old school with a new school twist heatsink around the outside, connected together with heat pipes. I mean, this already looks the business. You can see that they've spent a lot of time and packed a lot of stuff on. Top corner, you can see that you have 2 shielded 8-pin power connectors, and there is a fan header there. There's also a fan header in here as well, because you can see there are vents here, but that is to help cool the 10 gigabit Ethernet chip that is hidden underneath. There's a heatsink underneath there and a little fan just for the Ethernet. Now, I don't want to be preaching to the converted, but just adding 10 gig is not going to make your internet faster. Unless you've got 10 gigabit internet coming into your house, which don't think even exists. But anyway, this is for home networking. While we're around the back though, you can see we've got Wi-Fi 6, loads of connectivity, DisplayPort. Again, make sure that your CPU supports onboard video. Gold-plated connectors for the audio as well. Again, there's Japanese capacitors. ESS Sabre Hi-Fi. There is a separate section for the audio on the board, but we'll go back to fans. There's one fan header up here. Then you have CPU optional, CPU fan, system fan, and then system fan and pump. We come down the side, there's another system fan. Then we float around the outside, and there are 3 more fans down the bottom here. So we have 3, 4, 5, 6, 7, 8, 9 fans in total on the board, and that doesn't even matter. That's before you start to split them out with PWM splitters and stuff like that. Onboard power switch, onboard poster readout. There's also some onboard voltage points here for those of you out there that like to do things with a multimeter. 2 RGBs. One of them is your normal RGB, and then you've got an addressable. There are 2 more RGBs down the bottom, by the way. 2 normal USB 3 headers for the front panel, and then you've got a C-type as well. Thunderbolt down here. 6 SATAs. Front panel headers. There's a, is that your CMOS clear? I believe it is. I didn't know whether it was a CMOS clear or whether it was a sensor for, like a thermal sensor. There is the noise sensor, which is something that Gigabyte do. It's got like a little speaker on, and you can actually tune your fans with that. Some BIOS switches down in this bottom corner. Even though we've got lots of PCI Express main slots, effectively you get 16 times with that. If you drop a graphics card in, it splits it off into 8. But multi-graphics card seems to be phasing out like humongously massively. PCI Express 4 NVMe on the top, then there's a further 3 normal ones underneath this heatsink. Does have some lighting effects, but it's nothing to kind of like rock your world with. And then a large shield around the back for support, but it is also actively cooling some electrical components around on the back of the board. So we've had a good look around the board. So now we're on to performance and testing. Just so that you know as well, we tested with ABT enabled, just to stress things out that little bit more. The BIOS that we used was B5C, and this one was B6. This one does seem to have had a bigger impact, with things being slightly more positive though. So the graphs I'm going to show you are going to be marked for the Pro AX, mainly for shock tactics, because this is the worst of the bunch, but also the best in the bunch, which is really annoying. But anyway, so I will explain why. This one has had, I was worried after testing the Pro AX, and you'll see why in a sec. I thought the RTX was going to be really bad, and if anything, it's the best of the 3 for thermals, not necessarily performance. So I'm going to bring up VRMs for you first. Now, the reason why I'm bringing up VRMs is because I have a history with AMD, sorry, not with AMD, I have a history with Gigabyte and VRM temperatures. Now, electrically, all of these boards have been designed amazingly, and I have to stress that because I know they're going to flip their nuts because I'm saying bad things. Electrically, these boards are epic. 90 amp phases. I mean, the Pro AX has got 12 just for the CPU. So 12 90 amp phases should be more than enough, unless you mess up the BIOS. So as you can see with this, 106 degrees. Now normally 105 degrees things will start to throttle. Gigabyte have this thing though where they're like, well, they're rated to 125 degrees, so we're not going to turn anything down until they're actually at the point of overheating. Well, when it got to 106, I actually halted the test because it was, you could smell things were warm. And you could say you should have just tried to blow stuff up, but at the end of the day, I wasn't having any of it, and I actually stopped it. So, but when I did do that, one of the things I will say is the voltage with this is slack. It's better than it was at launch. So at launch I was seeing 1.66 volts, which is ridiculous, but that is within Intel spec. It's like someone has literally done, just like copied and paste stuff. I might add as well, the 1.66 is the highest volt that you can put on the board. If you go, they've got a thing called adaptive voltage, and if you go in there, the maximum you can put in is 1.66. So it's like they've not bothered to tighten it up. They just go, nah, CPU can do what it wants. We don't need to do anything else, and that's kind of the problem, and that's also why it's overheating. In the graph, though, you can see 1.35 volts. So what I did is I went into the adaptive voltage, set it to 1.35, and that puts a ceiling in, so that then the processor can't really go above 1.35 volts. And you can see it took 20 degrees off. It was still pulling loads of power, because that's also something that they've done, is they've kind of opened up all of the taps on the power, which means it pulls loads, and that also puts extra stress on the VRMs, because I'd still say for 90 amp phases, 86 degrees is still too hot. The other ones, you can see what the other temperatures were like with the other brands. It's just, they're pulling loads, and it's just because it's kind of untapped. But I'm going to explain to you why now they've probably done it. With the CPU temperatures as well, by the way. I don't know what's going on, but with the other brands and other boards as well, once they're at 100 degrees kind of consistently, you can see performance start to drop off. This doesn't. It's like, nah, we don't care. And I don't know whether they've turned something off in the BIOS so that it doesn't then start to throttle more. And this is purely speculation, because trying to talk to Gigabyte HQ is like banging your head on a wall covered in rusty nails. It's just, you don't bother. It's horrible. The local guy, lovely, he helps me and tries to help me so much. But you can just see that the stuff that's coming from HQ is just idiotic. So I've stopped asking questions anymore, because I never get answered. They never get answered. And normally what they'll do is, with this review, what they would have said if I'd shown them this beforehand, they'd be like, if you can, I know you've done all this testing. I know you spent like 2 days testing this one and writing it up, 2 days testing this one and writing it up, 2 days testing this one and writing it up. But can you wait a couple of weeks, and we're going to send you a BIOS, and then we want you to do it again. And then you wait 2 weeks, and it's then 4 weeks, and then eventually you go and test them, and they're all the same anyway, or the performance has dropped off of a cliff. But anyway, I'm ranting. It's just because I'm actually quite frustrated with this one, because with the Cinebench R20 graph up, the rest of the graphs are pretty much like this. This does really well. It's incredibly hot, it's cooking VRMs, but performance-wise, it's actually on point. But just look for this little puppy in the graph. Now, it does well in the graphs, but if you remember what the VRM temps were like, the VRM temps on that, and I'm going to bring it back up just to stress this point as well, you can see it does really, really well. It's not cool, but at the same time, it's not baking either, and the heat sinks on that are tiny. There's only 10 phases and tiny heat sinks. This has got 12 phases, so that it should be spreading the load, and they shouldn't be putting as much load underneath it. And the heat sinks are much, much bigger as well. The board's also enormous, so you've got heat soak galore, but it's just not kind of doing that well with this one. So keep your eye on this one while I'm moaning about this one, and I'm avoiding this one because I'll cover that at the end, because it does all right. You also need to remember, I have tested all of these with the i9. That's something I've not stressed enough. I've tested these with the i9. I've stressed them out as much as I possibly can do. Then we have the Vegas. Again, this is at the top. It does really well. And you can pick that one apart, but then we move on to gaming. And it's one of the few graphs where this one isn't at the top. And it's only just kind of beaten by the launch day Asus Hero, which that was the only thing that the Asus Hero did well on at launch. Gaming was great, everything else was a bit meh, and I do very much mean meh. It was the bottom of the graph in some of them. So the fact this one was second to top with that one, I actually think that's a win in the gaming sense. So performance is great with this. VRM temps, no. CPU temps, no. And in reality, it's BIOS problems. Under load, it was putting 1.45, 46, sometimes 1.48 through the CPU when other brands would have been happily there at 1.35, 1.36. I proved that it can happily run at 1.35 with benchmarks and stuff, which is why I turned that ABT down. I could even go even further. But once I pushed past 1.35 volts, there was a point where the temperatures, sorry, not the temperatures, the performance was starting, only slightly I might add, but it was starting to tail off. So 1.3 with adaptive voltage was a good kind of trade-off point for this. This one was just a little cracker. This one straight away was doing 1.36, 1.37 volts out of the box. You can tell the BIOS engineers have spent more time on this. The VRM temps were great. The CPU power draw was slightly down, but more often, more importantly, was the CPU volts were much tighter. So this one out of the three would be the one I'd buy. And you'll notice I've not mentioned the Master. The Master's like the most expensive one here. Performance was all right, it was middling, but the problem with the Master is it's so over-spec'd, it's such a high spec, it kind of means that you've got to want to be buying the i9. And the problem with that is I wouldn't tell you to buy the i9 for love nor money. So unless you really, really, really want the i9 and then you really, really, really want the Master, it's kind of a mute product. It's kind of the thing that it's going to slip into the background. It's kind of a bit pointless. Because if you have the i7 or the i5s or one of the i5s, you're not going to spend that much on a motherboard. I think you'd be nuts to do it. So that's why this one is kind of a bit meh. It's electrically brilliant. I will stress that because otherwise I will get phone calls and I'll get cried at. It's electrically brilliant. It's a brilliantly designed board. But again, the BIOS and the voltages and stuff, although the design of this is slightly better with the heat sinks and stuff, it is still overvolting. And the designers of the board, brilliant. Congratulations, cracking board, you've done some great work. Your BIOS colleagues, though, they've really let the side down, so we'll forget that one. But in reality, the Master's biggest problem is the 11900K, just so that you're aware. This one, BIOS boys, look, it's been out weeks and it's still not right. It's not good enough. If it came down to you're buying an i7, and this is, I'm not telling you to buy an i7 or an i5 or whatever, but if you're going to buy one of the K series processors, with this, until they fix the VRMs, I really wouldn't bother. It's getting too hot. And it's poor BIOS implementation. Because again, electrically, it's great. It's got 1290 amp phases. They should be fine. It's just all of the kind of firmware in the background letting the side down. And that's a reoccurring thing with Gigabyte, is the BIOS lets the designers down. And we're back to that point. But sadly, we're back to the point where the BIOS is letting the side down. But in reality, again, the design is pretty good. But this one, although it's not perfect, because the volts are still a little bit high, and it's nowhere near as quick as the Asus version, out of the three, this is the best of them. And in reality, if you wanted to build a high-spec i5, maybe a 600K board, but with ITX, then maybe this one. You need to remember though, because there's a lot of chatter online at the moment about buying the 10th gen and running it in one of the newer boards. You do need to remember, if you buy a 10th gen processor, it's only PCI Express 3. Now that's only in reality going to make any difference to super high speed storage. But with a lot of the stuff like the DirectX storage API coming, where quicker storage is going to start making a difference, and a positive difference in games, that is just something you're going to have to comprehend with. I mean, 3,500 megabits per second for PCI Express 3 is not to be sniffed at, and I'm just I'm giving you the information for you to decide yourself. It's something to consider in the future, because we don't buy and build a rig that costs many hundreds and quite often many thousands of pounds and dollars to then not think about what might be happening in 12 months. So out of the three, this would be the one that I would choose. but only on very limited circumstances. The other two, I just wouldn't recommend them at all, sadly. And like I said, the problem with this one is the i9, but the BIOS still lets it down. This definitely, the thing that lets it down is the BIOS, because the board itself is great, but the BIOS engineers, please someone go and change the batteries in them, or get them some help so that they can spend more time on stuff. And for the love of God, when you read an Intel white paper and it says the maximum voltage is 1.66 volts, that doesn't mean that you can give an end user with no experience a board that's going to feed its processor 1.66 volts. I actually stopped testing at launch because they were overvolting so much. Yes, it's better now, but it's still not good enough. They're drawing too much power, putting too much volts through, which is causing too much heat, and it's actually managing to stress out 90 amp power phases to the point where they're going over 100 degrees. How have they even managed that? So I'm going to leave you with that. I know not many people are even going to bother watching this, because at the end of the day it's Z590 and no one gives a monkeys, but I see it as being my job to bring you the information. I do the testing, and then you can come and see whether you should be making purchases or not. Or, not whether you should be, but maybe you've kind of decided that you need to, you have no other choice, or this is the way that you want to go, and you want to know whether maybe these are the boards you should be buying. Yeah. Anyway, this has been the tiniest one, with another video for you out. Ding! Love you, sis.